Once again, hello and welcome. We will talk about Gradle and IDEs and how these two tools can cooperate and what you can do to improve your developer experience. So my name is Radim Kubacki. I joined Gradleware team at the beginning of the year. I have some previous experience with IDEs and with Gradle and other build tools. So I was committer on NetBeans team in the past. I worked on Eclipse plugins and I did some development for IntelliJ plugins as well. What I want to talk about today is, after a quick introduction, we will discuss how Gradle integrates with IDEA, with NetBeans, and with Eclipse. So maybe if people who are using IDEA can raise your hand, so we can get, okay, it's like more than half here. Anyone using NetBeans? No one. Anyone using Eclipse? Yeah. Okay, good, thanks. So that means spending most of the time with IDEA is probably good. We will talk about Eclipse. I will say something about NetBeans as well. So let's start with IDEA, or let's begin with what we can do about the Ide integration and Gradle. We have two approaches that you can take. One of them is to start with Gradle and use one of these plugins that are distributed with Gradle and create all the metadata files that are needed by the IDE, and then basically the IDE doesn't have to know that you are using Gradle, because all what will happen is that it will find all the necessary information already prepared and will open the project, and you will be able to work with that. The other way is that the IDE will have its own support. And the reality is that all these IDEs have these supports now created, and the implementation actually has a lot of shared code. So things are similar, but the differences may affect your productivity or the way how you will use these tools. So if I start with IDEA, the thing is they improved a lot of things in their latest release, which is the major version 13. And you have Gradle support now as a part of IntelliJ Community Edition, and it means you don't have to pay for their Ultimate Edition. It's there for everyone. It's really nice, and there are various things that will make your life simpler. So obviously you can import your project. That's the first step before you start your work. And it would be nice to have the possibility to show the demo, but yeah, it can take a moment. So I can start with discussing some differences or how things in Gradle map to things in IDEA. And something's happening. Okay, so if you have a multi-project build in Gradle, the idea is that it will map to an IDEA project. Now, inside that multi-project build, you have Gradle projects, and those are mapped to IntelliJ modules. So it's one-to-one. It's usually created in a way where your sub-projects and root projects have their own project directory. So also in IntelliJ, your modules will have their own directories, but it's not really necessary. It should work even in the case that you will create sub-projects in the same directory, but there are not many people who want to do that. Okay, so we are there. Can we avoid that flickering?
Let's try your slide deck.
Okay. Okay, that's good. Okay, so I said we have Gradle build that is mapped to an IDEA project. We have Gradle projects that are mapped to IDEA modules. Now, the next thing is that if we talk mostly about Java, then you want to make sure that your Java project in Gradle is mapped as closely as possible to what IntelliJ can do about it. And this is mostly related to things like class paths. And class paths and source roots and the related stuff. So if you apply Java plugin, you probably know that you will get two source sets, one for the main sources, the second one for tests. You will also get some configurations created. Those are runtime, compile, test runtime. And we want to make sure that what you see in IntelliJ is really the same thing or similar thing to what Gradle will do. Why? The problem is that the way how these integrations work at the moment is that IntelliJ will build the sources on its own. And it's not easy to get rid of that. So we basically live with that assumption that for a while, if you are developing a project in IntelliJ, IntelliJ will build the sources, and if you run something in IntelliJ, it will create its own launch configuration and will run using its sources. It will use the dependencies taken from Gradle. But yeah, that duplication is there, and I'm not sure how long will it take to get rid of that. The good news is that with IntelliJ, you are still really close to what you see in Gradle. Because IntelliJ at least have those class paths where they can tell, this is a main source code, this is something what belongs to your application, and it's really the same thing that you have in source/main/Java, source, main, resources. So that works well. What you have in source test Java is mapped to IntelliJ's test scope, that's the name. They have 4 scopes, and these are provided, compile, test, and runtime. So the compile is what should be compiled when you are building your source base. And the test class path is something what should be used when you are compiling your tests. That means you have a dependency on JUnit that usually belongs to a test class path, right? And yeah, that what works well. You have also that runtime, which is something what will be added to your class path when the code is actually executed. And you don't want to see those things when you are building the code. There are some reasons why you want to do that. There's an example, like if you are building a RESTful service, you want to say that I will compile against that JSR API jar where the API is specified, and that will keep my code clean. I will use only things that are kind of officially supported, and it's independent on actual implementation. And then I will say, okay, put on the runtime class path the real implementation. And that prevents me from using something what is internal in Jersey or Moxie or something else what I will use when I'm really building the code. What I haven't mentioned yet is the provided scope. That's something what's at the beginning of the chain. And that's the best example is if you are building a web application. If you are building a web application, you will deploy to a container, and there's a set of things that are provided by that container. It's usually things like servlet API. It's there. Often some database pools and resource pools and things like this. So the distinction between provided and compile is that provided is visible when you are compiling the code, and it will be resolved when you are compiling, but it's not added when you are building things like your var. So it will not be added to webinf/lib, and that's the right thing. So perhaps I can start that demo. Talk a little bit, yeah. So at the beginning I said, okay, you can import the project. The project importer gives you some options like, do you want to use your local Gradle distribution that is installed somewhere, or do you want to use Gradle wrapper, which should be your choice because there are various advantages to that approach. Once you start that, once you say finish that importing wizard, it will create a model inside Gradle, and that's where this overlap between the approach where you generate metadata files using Gradle and when you use the built-in integration in IDEA is, because now it's doing the very similar thing as the Gradle plugin. It's calling Gradle, hey Gradle, give me the information about that project. It does few more things that the Gradle plugin does. Okay, so usually it takes a while. The bigger the project is, the more time, but in this case, I took an example from Benjamin's code that he uses throughout his book, Gradle in Action, and it's a simple web application. Again, what we have here is a Gradle code that uses Java plugin, var plugin. It uses Jetty to run that code. And there is also Eclipse WTP that we will need later. Dependencies are simple. It's provided compile, servlet API, and JSP API. That's the thing that I mentioned. We want to compile against servlet API because we have some servlet in our code base. We don't want to see servlet API jar inside the var. So that's why this is provided dependency. We have dependency on a to-do lib project, which I extracted from that original code base, just to show some inter-project dependencies. And we have some runtime dependency to add tag libraries to our var. We don't really need them when the code is built. Now, the other part is just a simple Java code with trivial test. How this is reflected in IntelliJ? You can see that IntelliJ will build those classes from our project into its own directory. That's that duplication that I was talking about. Now we have three modules here. One of them is associated with the root project of our Gradle build. The other two are the library and the web application. Now, these are dependencies from that web application. We will compile against the output from the lib. We will compile against Servlet API and JSP API, and those are marked as provided scope. Now, for a while, the built-in integration in IntelliJ did some smarter things when mapping those dependencies. We have fixed that with Gradle 1.12, I think. There were some edge cases where you wanted to map something into a test and runtime scopes. That's really a case that you cannot customize in that UI directly, but if you edit those XML files, it works. And yeah, apparently they wanted to see it working that way. So. Let's move on.
Excuse me.
Sure.
Just to orient myself here. So we imported the build.gradle file. Were actual IntelliJ project files generated by the plugin? Is that what you mean by editing the XML?
The actual IntelliJ files are generated by IntelliJ using the information provided by Gradle.
And when you said we could customize, what we were customizing what?
Okay, so at the moment we are not customizing anything specifically for this project. We can customize various things, how the Gradle view will be mapped to IntelliJ, and I will show some examples. Okay. Now the next thing is artifacts. When IntelliJ imported that project, it noticed that we have some artifacts created by that project, and in this case, it knows that if we are building web application, there will be web app module. That's useful when you want to deploy that web application directly from IntelliJ. Okay. So, pretty simple unit test. We can show that IntelliJ can run this, and yeah. It is not the same execution as you get if you run Gradle test. Why? Because the test is built by IntelliJ into its own output directory. The main source is built by IntelliJ into it.
Is there any plans to redirect it to actually using the Gradle timeline builder?
We don't really want to redirect it into the same directory as Gradle uses to build the sources. It doesn't work well. Well, you can do it.
Wouldn't it use like incremental compilation if doing that?
Incremental compilation is one of the features that we are working on, and yeah, we want to get it working well for all the cases. We still have various things that needs to be improved. And yeah, once we have incremental compilation, it will be all nicer. The thing is, what do we need to do to convince IntelliJ that it doesn't need to build its own class files, and it will be okay if they just spawn the Gradle build and let it build, let it run the test, and show the results. Not so sure about IntelliJ, but for example with Eclipse, where we have the same problem. The thing is that Eclipse wants to build with its own compiler because the output is immediately used to build their own database of things like indexes where something is used and all that information needed for find usages and refactorings and that kind of stuff.
This has been like an issue for our team because we have like customers properties set in the Gradle file. Our build is like multiple project dependencies set up in like a somewhat complicated way. So I want that.
Okay, so there are some ways around that, and one of them is that you can customize your Gradle build and say, hey, when you are generating that module file for IntelliJ, add a section, or it's probably not a module file, it will be probably in a project file. Generate that launch configuration and set those properties there immediately. So I will complete that demo, and I can probably show it on example of the Gradle code base itself. So if I can continue with that, yeah, here I can show you that we can launch that web application using IntelliJ. We will create the configuration that starts Tomcat that is installed on that machine, and it will deploy one of these artifacts that were discovered when the project was imported. Yeah. Let's get it running, and yeah, that's the application. Okay, so let me show you that thing with Gradle. And if I open that, I can guide you through a few more things that we do for our project. Not yet there. Is it readable now? I guess we still want. Okay, so that's a customization that is done in the Gradle code base. And if you take a look We are mapping resource directories into a runtime and test configuration to make sure that the resources are available when we are executing code inside IntelliJ. Not sure if this is really necessary for the latest release, but probably it is. We are setting language level. Yeah, I think there's a pending item to export that information about the project in the tooling API. So yeah, it needs to be set in this way. And that's basically where you do all these customizations. Yeah. Can we adjust the projector so that the whole screen is visible? Thank you. So all these customizations that you want to do, and you want to affect the way how IntelliJ project is generated, are in those sections inside the IDEA closure, and there's IDEA module, there's IDEA project. So for the module, we don't do too much. For the project, we have more stuff. Now that IPR is basically a closure that is called when the XML for the IPR file is created. So with that XML, we can do a lot of things. And the good thing is, once you put it there, it's shared by everyone in the team, and you at least get a consistent output from that import into IDE, and it works for the command line invocation using Gradle IDEA. It works for the import inside the IDEA. So what we are doing, and what is interesting here is for our code base, we are excluding some sources, because as you have seen at the beginning, we have source code level 1.5, and we have some packages where the code is compiled with 1.6 or 1.7, so we don't want IntelliJ to touch these packages because it doesn't work well. The common snippet is that one with VCS mapping version control system. We just tell IntelliJ, hey, this is a Git repository, and it knows how to do the rest. We are setting Gradle home, SDK home. Yeah, we are setting license to Apache, and we do a few more things here. These are settings for the code style. Not so interesting, but here inside the workspace, which is the section dedicated to how the workspace file is generated, we are using some things to generate a run configuration, and this run configuration is used to call Gradle itself. So you can do something similar and generate a run configuration that will run your tests, and you are able to say option program parameters and pass your properties and do stuff like this. It's not very elegant solution, but yeah, it should be working. So that's probably the way how. Yeah.
How discoverable is this? In other words, when let's say the scenario is you have IntelliJ, you import or open the build.gradle file, but rather than this being in the build.gradle file, this itself is in a plugin, perhaps a plugin you've created that configures things. is the integration with IntelliJ smart enough to go and just look for this kind of construct programmatically rather than any kind of parsing of this? Or is this not doing this declaratively when it searches for it? It looks for the right data structures, or how does that? I was going to want to take this stuff and make it something that would be a custom plugin for my organization. I won't have this in every build file necessarily. Will the integration find it?
Yeah, it should be possible. So the question is, how do I make it possible that this will be something shared in my organization and applied to everything? And yeah.
No problem. Cool.
That's possible. You can create your own plugin and do customizations. You can also make sure that your distribution will apply IDEA plugin and will do some configuration for the build scripts. Like if you see that this project applies Java plugin, apply IDEA as well, and do this configuration. That's roughly the idea.
When you do Gradle IDEA, but you're saying it'll work if I import that.
Yeah, it will work as well.
If I do Gradle IDEA.
Yeah.
That's good.
At least I believe. if I hope I'm not confusing. Okay, so in the end, yeah, the project itself is imported there, so you can see that the Gradle is there. Quick check, and quick check is something what will run Gradle with some argument. Again, that's something what you can see. See it here. Okay, so anyway. Now, let me say something about those differences between using Gradle IDEA and the import itself. So why you want to use one or the other version? I think with the Gradle plugin, it should work consistently. And yeah, we are trying hard to make sure that it's working. The baseline, I think we are working with several IntelliJ versions. So recently, I think we have all switched inside the Gradleware team to IntelliJ 13, but previously we used Gradle 12 for a long time. IntelliJ's integration is sometimes broken. It happened several times recently when we released new version of Gradle or a new release candidate. We discovered that there is a problem. They usually fix it quickly, like within a week or two, and they publish their early access builds. And we hope that there will be less cases like this. And usually the problem is that they use something internal inside Gradle, and they do this to improve their integration. And we are talking to them. We have a list of things that they want to see done and publicly available as an API. And we are slowly reducing that list. And yeah, sometimes it happens that on the way to get there, yeah, we break some of these things temporarily. What I said is that there was a better scopes mapping with the older version of Gradle. Also, the current version IntelliJ 13 is more correct when recognizing what is a source set and resource set. So if you have main Java subtree, the IntelliJ will import the project and will know, hey, this is a subtree where Java sources are located. It also adds main resources to your content roots. That's the term from the IntelliJ, and will know, hey, this is the place where resources are. So the difference is that when you do like new class, it will offer you, hey, you want to create that new class under that tree, and it will not suggest you that you will put that source file into resources tree, because it doesn't make sense. So these are some of these small improvements. What they are doing better is they have improved support for build file editing, something what we are not setting really well when the project is generated from the Gradle plugin. So if you are editing Gradle file imported by their plugins, you will see those hints like make sure that sources are available for IntelliJ for the Gradle code, and that helps IntelliJ to show you Java docs for various things, like when you are typing repository, it will tell you something what is searched in the Java doc and things like this. Okay. Also, there is one more thing. If you want to use IntelliJ, you don't really have to say apply plugin idea if you want to use that import wizard that is part of IntelliJ. It's kind of a small thing, but yeah, it can be nice in some cases. So if you go back to slides. Okay. Now, there is no one who uses NetBeans, right? I will try to make you interested. What's the main objection? Or have anyone tried that? Or there is no built-in support in Gradle as such. But the thing is that NetBeans plugin can successfully live on a model that is used by IDEA. It doesn't really need to use anything better. It's not shipped as a part of the default distribution like with IntelliJ. You have to download it, but the download is available just from the distribution. What's there? Things like ClassPass are working, building is working, running works as well. Things that are not so good are things like web application support and similar things. On the other hand, there are some advantages. If you use NetBeans plugin, then it's really building using Gradle. We skip that thing where the IDE builds in its own way and Gradle builds on its own. So, yeah, NetBeans plugin will call Gradle build. If you want to run a test from NetBeans, it will call Gradle test -- test single equals class name and optionally the method name and things like this. So there is some overhead when calling Gradle this, when you running the test this way, because you have to call Gradle and look what's the output, and yeah, probably you want to be really fast when executing unit tests. The turnaround should be like second, and you should be done. So that's one of these things that we want to improve continually in Gradle to make sure that IDE can use this way for their integration, and we will get the response really quickly. There are ways how you can add your own action that will call various things in Gradle, like build this task, build another one, and stuff like this. But yeah, the plugin is created by a volunteer in Hungary. It is currently active. Not sure what the future will be, but yeah, it usually depends on the community. So the example that is demonstrated here is simply a multi-project that you can see in Gradle distribution. If you go to samples, Java multi-project, it's a simple project with an API library and web service and some shared libraries and dependencies between those. Nothing really complex, but yeah, at least you can see that the class path is there and it's working.